Hello everyone, welcome back to VLSI Simplified. In today's episode of our interview questions series, we are going to discuss some really important RTL design interview questions that are often asked in companies like Synopsys, Qualcomm, and eInfochips. Let's get started. First question: what is the difference between combinational and sequential loop in RTL? Combinational loops are when output feeds back into inputs without any clock, which makes the design unstable and is not recommended. Sequential loops, on the other hand, have flip-flops, so they are stable. So, the key takeaway: always avoid combinational loops in your RTL. Race around condition. How do you avoid race around conditions in Verilog simulation? Race conditions happen when two always block update the same variable at the same time. To fix this, always use non-blocking assignment in sequential logic. Third question: what is the difference between initial and always block? Which one is synthesizable? The initial block runs only once at time 0 and is not synthesizable. Always block runs continuously and is synthesizable if coded properly. So remember, initial is used for simulation, always is used for hardware. Now, how are multipliers and dividers synthesized in hardware from RTL? Multipliers usually get mapped into shift and add logic or DSP blocks. Dividers are more complex, so they are implemented using iterative logic like subtract and shift. Next, what is retiming in RTL design and why it is used? Retiming is when synthesis tool move flip-flop across logic to balance timing. It helps improve improve performance and meet timing closure. Now, what is the difference between blocking delay in Testbench versus RTL code? In Testbench, we use delays like hash 10 or for simulation, but in RTL, delays are not synthesizable. Real hardware timing comes from clocks, not delays. Now, how do you ensure your design is free from unintended latches? By converting all if-else conditions, writing complete case statements, and giving default assignments to signals. Now, explain one hot encoding versus binary encoding in FSM. Which one is better? One hot uses one flip-flop per state, faster but uses more area. Binary uses fewer flip-flops, smaller but slower. So it depends on area versus performance trade-off. Now, what is the difference between clock gating and power gating? Clock gating saves dynamic power by stopping the clock. Power gating cut off the power completely, reducing leakage. Both are very common in low power design. Now, last question. How do you write RTL code for a priority encoder and avoid latches? Simple. Always give default values first and then cover all input cases properly. That way, no latch is inferred. So that's all for today interview question series 3. I hope this helped you in RTL design interview preparation. Don't forget to like this video, share it with your friends and subscribe to VLSI Simplified for more such interview focused content. See you in the next video. Thank you.